Hi everyone. I received another question from somebody applying for a job in electrical engineering who had the simplest question ever when they applied. It was possibly over Zoom, and someone gave them, think of a 3-volt battery in series with a 1 ohm resistor. Tell me the current and talk about this circuit. And if you are taking 285, hopefully even if you haven't taken 285, you know that this is the plus and this is the minus side of the battery, which means really we put a potential difference there on the 1 ohm, and we impose a current flowing through that 1 ohm of 3 divided by 1, so it's 3 amps. So the student said, well, the current is 3 amps in that direction. And now talk about the circuit. The student answered, not a student, actually an engineer, answered power is V times I. So the power is 3 watts here. Oh my gosh, 3 watts on the circuit. So we're delivering 3 watts to that resistor. Now, there's a lot more that you can say about this circuit. So this was the end, and I think because of that, the alum reached out and said, what should I have said? And so that's why I'm making this video. There are many things you can say about this circuit. The 1 ohm resistor is a very high load. This 1 ohm, because of the 3 amps, 1 ohm is very large load, because from the perspective of the battery, of the 3 volts there, the battery needs to supply 3 amps. And often, for example, a 3-volt battery would have a 1 amp hour, and so this circuit will die if the battery is 1 amp hour. Circuit will die, will stop working in 20 minutes, right? Because you're using 3 amps instead of 1 amp, so in 1/3 of that hour, we're using up all the battery. So of course, if it's a 3 amp hour battery, you go for 1 hour on that circuit. So you could also say that the person who designed the circuit is probably a physicist. That's not very good to say, but as an engineer, if you want to just show a circuit, instead of 1 ohm, you'd like a 1 kilo ohm, and the circuit would work for a much longer time. And the current obviously would be 3 milliamps, and you'd not be scared of putting your finger here. So second thing is, you should be scared. It's like, oh my gosh, it's 3 amps are going through here. This resistor here, the resistors that we currently have in the lab, and chances are many resistors that you see that are this big, are 1/8 ohm, 1/8 watts, or a half a watt is the big, much bigger resistor. Unfortunately, yeah, I should have brought one. So these here, for a 3-watt resistor, that means it's a big, even big in size, big resistor and big load, because it needs to not heat up too much. So in terms of packaging, it's going to be a very large packaging, this resistor. So the size of that, even though the number here is small, this is a very big load because it requires high current. This is a very high power circuit because it's 3 watts is a lot to use power, or to even deliver power. And what else? I think that's it. I have the feeling I had something else, but at least for now, I hope this helps you talk more about something so simple that really I end up not teaching in class. Like, why is it important to know what the load is in a circuit? In terms of heat dissipated, that's going to be super hot. If it's a half a watt, chances are it's going to start melting. If you put your finger there, your finger's going to burn. So you can continue to talk about the circuit for a long time. And it's a very smart way to ask how much experience you have in circuits, actual hands-on experience you have in circuits. People who are only doing this on paper usually don't know to talk much about something like this. So I really hope this helps. And if you encounter this problem, it's like, well, how would you redesign the circuit with that same battery? It'll be very, very easy. Put a 1 kilo ohm resistor here and a 3 volts here. Chances are the person who has a 1 ohm resistor will have a 1 kilo ohm resistor too, or a 10K. Anything around 1K, 10K is so much better. And then you'd have a 3 milliamp current. It's much more reasonable to do a circuit like this. So that's it.